G'day. In this video we're going to be looking at our graphs of, we'll just do sine and cos in this video. So y equals sine x, y equals cos x. So let's just have a look at each of these in turn, and then we'll look at how to sketch transformations of them. So sine, sorry about my poor graph, but this is just a quick video on roughly what it looks like. So sine passes through the origin. That's how to remember it. It changes sign as it goes through the origin. So that's a good way to remember the graph of y equals sine x. It has a period of 2 pi. In other words, it goes through an entire cycle after 2 pi radians. So that means halfway is pi. So it's 0 there, and it means at your peak there, that's pi on 2, and at your nadir down here, your minimum there, that's 3 pi on 2. And so they're your values, your main values, and it just keeps on going forever, on and on and on. And so it's really important to be really comfortable with this graph, y equals sine x, knowing where it intersects, where the key important points are at those values. And something I didn't put on here, that's -1. And that's 1 up here. So that's really important to know this graph intimately. Okay, so that's sine. Let's have a look at cos. So cos. Let's put cos. Now cos starts at 1 and comes down. People get a little bit more confused by cos, like knowing where it starts and finishes and things like that. So let's do that. So there's 0. So that's the start of the cycle up there. Let's say it's the start of the cycle from 0. And so where has it done one complete cycle? That's up there. And so so that point there is 2 pi. Y equals cos x has a period of 2 pi as well, just like sine x. So that means the halfway point here is at pi, and that's where we get our minimum of -1. Down there, and I forgot to write it in again, but 1 is there, and halfway between there's 3 pi on 2, and there is pi on 2. So they're your important points there that you really got to know these well, because they start moving around when we start doing transformations. But they're your graphs there. Okay, so hopefully you're comfortable with them. Let's just have a look at. I'll do this nice and big. I'll just do it with sine, because it's basically the same for both. So sine, and I'll go n x minus h plus k. Okay, and so it's just really good to know what each of these things do. Okay, so the value of a. What does a do to the graph? If it's negative, it'll reflect in the x-axis. Okay, so instead of going like this through the origin like that, that'll get flipped down to there. That'll get flipped up to there. It's a mirror through this image here, so everything gets flipped upside down if a is negative. Okay, so that's the first thing that happens. A also tells you what your amplitude is going to be, and your amplitude is just the distance from the middle of the sine graph to the top. Okay, so that will be a. That's the size of that. In other words, if a is equal to 2, then that height there will be 2. If a is equal to half, then the height of the wave will be half. That sort of thing. So that's what a tells you. It dilates it in the y direction. Okay, that's good. So that's a. Get rid of that. Let's have a look at this value n. What does n do? N dilates in the x direction. Okay, so if n is big, then it gets squashed. It squashes up the graph of sine x. In other words, you get sort of that sort of thing going on. If n is small, then you get expanded. It's probably a better word than that, but it's like long, like that sort of thing. So that's what the value of n does to the x direction. If n is negative, then you get a reflection in the y-axis. Okay, so if you look at the graph of sine x or something like that, that sort of thing, this gets all reflected, so that goes to here and that goes to there, that sort of thing. It's getting reflected in that line there. Your x values are becoming negative. Okay, and so that's what n does. And finally, h, that's how much the graph moves to the right, and k is how much the graph moves upwards. Okay, so that's what all these parts do to it. Now, I'm not going to do it for cos as well, but the same applies to the graphs of cos. In fact, the same applies to every single type of graph that you can think of. It's really important to understand that these transformations exist and that you know how to work with them. Okay, so let's just have a look at it. I'm just do a couple of quick just to sort of show it. I'm not going to labour the point. Equals 3 sine x over 4. Okay, so let's have a quick look at that. So this has an amplitude of 3. It's been stretched by 3 in the y direction, and also this is like a quarter x, and so what that does is it actually expands the graph out by a factor of 4. It makes it fatter. Okay, so just a reminder of what sine x looks like. It goes up like this, okay, to 2 pi. What's going to happen here is that instead of going from 1 to negative 1, it's going to get stretched by 3. Okay, so let me draw this for starters. So instead of going up to 1, it's now going to go up to 3. It's got an amplitude of 3, and this is going to stretch it out by a factor of 4. So one rotation here, rotation, sort of cycle, that sort of thing, that's instead of 2 pi, it's going to get stretched out by 4. It's going to go to 8 pi. The halfway point will be 4 pi. This maximum height here will occur at 2 pi, etc. So you just sort of got to work it out. It's been stretched out by a factor of 4, and so you could do negative 4 pi there and that sort of thing. Okay, and so that's what the graph will look like, and that's it. You could label these points up here, but it's sort of obvious from the graph what's going on. So let me just do another quick one. Okay, y equals negative half cos 2x, something like that. We'll do this one. So the amplitude here, the amplitude will be half. That's the amplitude. So it's going to go up to a half and then down to negative half. Okay, and the graph of cos x would normally go, I'll put it in a dotted line, normally go like this sort of thing, like that. And let's just think about what happens to it. Now this cos 2x, that's going to squish it in by half. So instead of 2 pi being out here, it's going to squish it up, and so one cycle is only going to be 1 pi. So, because instead of going to 2 pi for one cycle, it's going to be split, squished into half. So it's only going to go out to pi. Also, we've got a negative in front, and so what happens is it flips in this mirror line here. So in this axis, the x-axis, it's going to flip in there. So it's actually going to be upside down like that. Okay. So we'll now sort of kind of try and draw that, and we'll give that a go. So I'm just waiting for all these to disappear. There we go. Get rid of them. Okay. So what's going to happen is it's going to go to red. It's going to start down the bottom because it's upside down. And it's going to come up and down, up and down, etc. Like that. And up and like that. Now, if it starts here, then what did we say the period was? It's going to be pi because it's getting squished by half. So instead of 2 pi, it's pi. So that point there is going to be pi. Halfway here is pi on 2, and this point here is going to be 3 pi over 4, and that point there will be pi on 4. Okay, so there are your points, and you could extrapolate and do these ones. That's 5 pi on 4, 6 pi on 4, etc., etc., and there's 0. And then you've got your maximum minimum values. And so that's what the graph looks like. Okay, so get used to these. You need to become good at them. I think I might have time. I'll just try to do one more example of translation. Hopefully I've got time. Hopefully. Let's just do something like y. I'll just try and do 2 sine, and we'll have, we'll do something like this, 3x minus pi. Yeah, that'll do. Okay, 3x minus pi. Let's sketch this one here. So what is this? Now, the 2, that gives an amplitude of 2. That's nice and easy. That just stretches it upwards. That's no problems. The hard thing about sketching trigs is when you've got transformations in the x direction, and that's what we've got here. Now, this is actually not written in a correct way. Well, we need to just rewrite this as 2 sine, and then take the 3 outside of a bracket, because this is actually what the transformation is. So we write x in there, we've got 3x minus pi. If we take the 3 out of pi, then we get pi over 3. And you'll see if you expand that, 3 times negative pi on 3, that's negative pi, so that's right. This is the true representation. This is how you need to have it written. This is your amplitude. So that doubles the height of the wave. This will squish it in the x direction by a factor of 3, and then what will happen here is this will move it by pi on 3. So what this is the same as y equals 2 sine 3x, same as that, but moved pi on 3 to the right. I'll just put R for right, move to the right. Okay, so just a quick little sketch of what y equals 2 sine 3x will look like. It goes from 2 to negative 2. It's going to go through the origin because it's sine. 3x, it's going to divide it up by 3. And so instead of going to 2 pi, it's going to divide it by 3. So it's going to be at 2 pi on 3 when it's done one rotation. I've picked bad numbers here. Okay, 2 pi on 3. That's where it's going to do one rotation. So it's going to go up and down and like that. Okay, and keep going. Okay, so 2 pi on 3. That means here it's going to be half of 2 pi on 3, which is pi on 3 there. Pi on 3. And that's, I'll just do this one too. Half of pi on 3 is pi on 6. And here it's going to be 2 pi on 6, 3 pi on 6, which is pi on 2. Okay, so they're all your important points. Now, let's move all of this by pi on 3 to the right. So let's try and draw this now. I'll do it a bit bigger. Okay, that's the best line I've done in a while. So it's still going to go between 2 and negative 2 because the y is not being affected, it's not being moved up or down or anything like that. But all the points are being moved by pi on 3 to the right. So let's start with the one at the origin. That's going to be the middle. Instead of being there, it's going to be at pi on 3. I'll just mark some of these things first. So we'll have pi on 6. We'll have 2 pi on 6. 2 pi on 6, 2 pi on 6 is pi on 3. We'll have 3 pi on 6. We'll have 4 pi on 6. 5 pi on 6. And pi. And that'll do us, okay? So instead of crossing at 0, it's going to cross at pi on 3. So I'll go to green. It's going to come through like that, okay? Where's its maximum? Instead of pi on 6, it's going to be moved by pi on 3. So pi on 6, this is how you should start thinking. Pi on 6, it's going to be moved by pi on 3, which is 2 pi on 6. So that's going to be 3 pi on 6, which is pi on 2. So up here, that's where it's going to be its maximum, up there. Okay. Where is it going to cross back down? At pi on 3 here, but it's going to be moved to the right by pi on 3. So that's 2 pi on 3. So it's going to be here. So we're actually lucky here. So it's going to go up. Oops, what have I done? Screwed up the graph by clicking onto the pencil. I'll just undo that. So it's going to go up and down. You can see it's going to continue in that fashion. Up like that, etc. Okay, so the key points are here to understand what the reflections and dilations do. Apply all those things first and you do your translations last, okay? Move things last. Write a sentence out like this might help you draw this one, sketch that one quickly, and then it moves by pi on 3. That'll help you to understand what's going on. Okay, hope that all makes sense. It is very tricky. It's something you need to get a lot of practice at. Enjoy.